now we will discuss another case in which man wants to cross the river and wants to exactly reach the opposite point of the bank. Okay, we have discussed the case in which he wants to cross the river in the shortest time. Now this case is called crossing the river in shortest path. Okay, let me explain it to you first. Suppose there is a river. Okay, there are two banks, one and the other one, and there is a man, suppose at point A. Okay, and he exactly wants to reach the opposite point on the other bank, which is point B. Okay, and also the river is suppose flowing with velocity Vr. Okay, and man can swim at suppose velocity v of man with respect to river Vmr. Okay, this is velocity of man with respect to river. We know that this means that this is the velocity of man when the water is stagnant in the river. Okay, when river is not at all flowing, then if you measure the velocity of man, this is Vmr. Okay, now since river also starts flowing, if he tries to directly swim towards A to B, okay, from A to B, the river will also drift him. Okay, keep on drifting him towards the right, and he will not be able to reach the point B. Okay, so what he has to do is he should apply all his effort in some direction, okay, at some angle phi, suppose, with this line AB. He should swim a little towards left from line AB, so that the resultant of this river velocity and the man's velocity Vmr, okay, this is Vmr, these two velocities, okay, combine to give you a resultant towards A to B. Okay, in this way he can reach exactly to the point B. So let me explain it to you here. See what will happen if we want that the drift should be 0 here, that is he should not be drifted from this line AB. Okay, then the velocity along x direction should become completely equal to 0. His velocity in the y direction should be present. This is the y direction, suppose, and this is the x direction. So he can have velocity in the y direction, but his velocity in the x direction should become equal to 0. Okay, so this was the explanation. Now let us understand it in detail. In this case, the man swims in the direction perpendicular to the river flow as seen from the ground. Okay, his effort is at an angle with AB. Okay, but from the ground, if you see, he exactly swims perpendicular to the river flow. Let me show you the diagram. Okay, again I will draw this diagram. What I told you, if man wants to reach from point A to point B, he has to apply all his efforts at this angle. Suppose this velocity of man is with respect to the river, and since river velocity is in this direction, in the right direction, Vr, okay, so this velocity will also be combined with the man's velocity. So this Vr will also be taking the man in the right direction. So what will happen? Suppose this angle is phi. Okay, the component of Vmr in the direction of AB will be how much? This is Vmr, how much? Cos phi. Okay, in the line of AB and perpendicular to this, okay, opposite to the river flow, the component will be Vmr and sin phi, obviously. Okay, because if we take component of any vector towards the angle in which direction we know the angle, the component is vector into cos theta, and perpendicular to it, the component becomes vector into sin theta. Okay, so if the man is not supposed to have any velocity in the x direction, his net velocity should be 0. Okay, so if I write his net velocity in the x direction, what I can write is, see, in the x direction, his velocity, net velocity in x direction will be Vr in the right direction, okay, and Vmr sine phi, okay, in the left direction. So I have subtracted, okay, Vmr sine theta from Vr. Now, if Vx is supposed to be 0, so I will write for zero drift, okay, zero drift, okay, for zero drift, Vx should be equal to 0. Vx should be equal to 0. That is, his x velocity in the x direction will become 0. In that case, only the velocity Vmr cos theta will help him cross the river. Okay, Vmr cos theta along line AB will help him cross the river, and the velocities in the x direction will become 0. So drift will become 0. So from here we will get, see, sine phi will be equal to Vr, okay, upon Vmr. Okay. So from here we can get the value of that angle at which the man is supposed to swim or apply his effort so that he can exactly reach the point B. Okay. Look at this carefully. Okay. See, now, so again I have written this point again. For minimum drift, the man must swim at some angle phi, okay, some angle phi with the perpendicular in the backward direction. What it means is, in the backward direction means at some angle like this, okay, backward with respect to the river flow. Okay, this angle is phi, and the value of phi is calculated from here. See, sine phi can be calculated as Vr, that is the velocity of river flow divided by man's velocity with respect to river, that is Vr upon Vmr. Okay, if the man swims at this angle opposite to the flow of river, then he can exactly reach on the opposite point, that is point B, starting from point A. Okay, chalo. Next thing is time to cross the river along the shortest path. So we had seen that if this is Vmr, okay, this is river velocity, then man's velocity is Vm. How can we see this? See, first of all, let me explain you. Dekho, man ki velocity with respect to river we can write as Vm minus Vr. Okay? Ye, we have seen this type of equations many times. Okay, man's velocity with respect to river can be written as Vm minus Vr. So net velocity of man with respect to ground, that is his absolute velocity, his actual velocity as observed by any observer on the ground, will be Vm, and this will be equal to, see, Vmr plus Vr. Okay, so what it is actually, man's velocity will be sum of man's velocity with respect to river, that is the effort velocity, plus velocity of river. Both these velocities will be added to give the resultant velocity of the man, which should be along the line AB. So actually Vm is the velocity which is helping the man to reach, okay, to point AB. So clearly that Vm is actually what we had seen, that Vm, the remaining velocity is actually Vmr cos phi. We had seen in the previous slides. Let me explain it to you again. We had taken the components. See, since x velocities were cancelled, only y velocity, that is Vmr cos phi, will be left, which will take him across the river. So suppose the width of the river is d, Okay, so we can calculate the time of the man in which he can cross the river. So if width is d, okay, d is what? D is here width of river, okay, and the velocity which is taking him across the river is how much? VMR cos theta, cos phi, VMR cos phi. Okay, so in this triangle, if we see, okay, vector sum of VMR plus VR will give us VM. Okay, this is the line of VM, vector VM in the direction along AB. Okay, so can we calculate cos phi here? That will be based upon hypotenuse. Okay, and hypotenuse is how much, beta? Hypotenuse is how much? We can calculate easily, right? So VMR cos theta is, cos phi is this much. So hypotenuse square minus perpendicular square. So that will be VMR square minus VR square. See, let me derive it for you. This is actually how much? VM only. Okay, so VMR square plus, sorry, should be equal to VM square plus VR square. Okay, so clearly VM will be equal to VMR square minus VR square. So VM square will be equal to VMR square minus VR square. Okay, तो यहाँ से टाइम भी हम लोग निकाल सकते हैं. Otherwise directly you can put the value of cos phi here and directly you can get the time in which he will be able to cross the river. Okay, see, let us take a question here, and so that we can improve our understanding. See, a man can swim at a rate of 5 km per hour in the still water. Okay, still water means that if the water is stagnant, then the man has the ability to swim at how much? At 5 km per hour. Okay, if the water was not flowing. A river of 1 kilometer, a river which is 1 kilometer wide. Suppose this is the river and its width is how much? Its width is 1 kilometer. Okay, is flowing at the rate of 3 km per hour. So river velocity, it is 3 km per hour. Okay, now the man wishes to swim across the river directly opposite to the starting point. So if man is here, okay, he wants to reach point B. So if he applies his efforts along a B line, then what will happen? He will be drifted in this direction, okay, and he will reach some point C. So what we had discussed just now, that he should apply his effort, okay, he should make an effort to swim in this direction a little bit against the flow of river, so that the velocity of river is cancelled. Okay, suppose he is swimming at some angle phi here. Okay, at some angle phi, his velocity, the velocity with respect to the river is 5 km per hour. Okay, clearly, if we break this into components, the y component will be how much? 5 cos phi, 5 cos phi, and the component against the river flow will be 5 sin phi. Right? This is the question. So, this was the explanation. Now, along what direction must the man swim? So, we just have to find the angle at which the man should swim. Okay, so let us find that angle. देखो यहाँ पे क्या हो जाएगा? He should be able to cancel that 3 km per hour with his speed 5 sin theta, which is opposite to the river flow. Or directly we can use the formula that sin phi is equal to how much? It was VR आर अपॉन वी एम आर। ठीक है, ये भी यूज कर सकते हैं डायरेक्टली, या फिर मैं देख सकता हूं कि यहाँ पे जो 3 किलोमीटर है वो 5 sin फाई के बराबर है, तो डायरेक्टली ऑल्सो वी कैन राइट। तो रिवर का फ्लो बेटा यहाँ पे क्या है 3। ठीक है, मैन का वेलोसिटी विथ रेस्पेक्ट टू द रिवर क्या है बेटा 5 है। तो फाई एंगल क्या हो गया, द फाई एंगल इज इक्वल टू साइन इनवर्स 3/5। ठीक है, जो एंगल हो गया उसका फ्रॉम द एंगल ए बी, फ्रॉम द लाइन ए बी, दैट विल बी फाई इज इक्वल टू साइन इनवर्स 3/5। ठीक है, दिस इज एक्चुअली अप्रोक्सीमेटली इक्वल टू 37 degrees. Okay, this is equal to almost 37 degrees. Chalo, let us see. So we have got this answer, this one. Along what direction the man should swim? So he should swim at angle how much? At angle 37 degree from perpendicular line. From perpendicular line. Okay, first answer we have got here. Okay, now the second question comes, what should be his resultant velocity? Okay, so his resultant velocity will be actually how much? It will be, see, Vm, suppose I write Vmr is equal to Vm, okay, minus Vr. So this is the resultant velocity. Okay, so Vm will be equal to Vmr plus Vr. ठीक है, दोनों का रिजल्टेंट होता है एक्चुअली these two vectors after adding give the resultant velocity of the man. ठीक है, तो going back to the diagram, देखो इस डायग्राम में देखें बेटा, तो देखो 3 किलोमीटर पर आवर was cancelled by 5 sin phi so that the drift becomes 0, okay, along the flow of river. So only 5 cos phi is left. Only how much is left? 5 cos phi is left. That will be his resultant velocity. ठीक है, दोनों का जो रिजल्टेंट आता है वो a b के along में ही आ जाता है। ठीक है, ये वाला, और इसका वैल्यू क्या होता है एक्चुअली, देखो VMR cos phi। ठीक है, VMR cos phi, तो वो कितना हो जाएगा, देखिए VMR इज हाउ मच, इट इज 5। ठीक है, एंड यहाँ पे क्या लिख सकते हैं हम लोग, cos 37 डिग्री, cos 37 डिग्री इज अप्रोक्सीमेटली 4/5। तो इसकी जो रिजल्टेंट वेलोसिटी हो जाएगी बेटा y डायरेक्शन में हो जाएगी, एंड दैट विल बी 4 किलोमीटर पर आवर। ठीक है, 4 किलोमीटर पर आवर हो जाएगी उसकी y डायरेक्शन में वेलोसिटी, एंड दैट विल बी हिज रिजल्टेंट वेलोसिटी विथ विच ही विल बी क्रॉसिंग द रिवर अलोंग AB लाइन। ठीक है, तो हाउ मच टाइम द मैन वुड टेक टू क्रॉस? तो इसके लिए बहुत ही सिंपल सी बात हो गई भाई कि टाइम वॉज इक्वल टू द विड्थ ऑफ द रिवर डिवाइडेड बाई द रिजल्टेंट वेलोसिटी। वो हमने अभी अभी देखी क्या थी, वो VMR cos phi हो जाएगी वो। ठीक है, VMR cos phi हो जाएगी, एंड वी हैड जस्ट सीन, देखो कि ये 1 किलोमीटर दिया हुआ है। इट इज गिवन इन द क्वेश्चन दैट द विड्थ ऑफ द रिवर इज हाउ मच, इट इज 1 किलोमीटर, एंड द वेलोसिटी इज हाउ मच, इट इज 4 किलोमीटर पर आवर। 4 किलोमीटर पर आवर, वही है उसकी y वेलोसिटी VMR cos phi। ओके, तो बेटे यहां से क्या आ जाएगा, 1/4r, 1/4r, या फिर इसको हम लोग कितना लिख सकते हैं बेटा, 15 मिनट्स। ठीक है, इफ वी मल्टीप्लाई दिस विथ 60, 1 आवर को हम लोग क्या लिख सकते हैं, 60 मिनट्स लिख सकते हैं, राइट। सो वो क्या हो जाएगा, 1/4 into 60, तो वो क्या आ जाएगा 50 मिनट्स। ओके।